In this fifth unit, we are going to see here is architecture of an TMS320C54x. So this is an advanced version of 5x processor, and this TMS processor also is going to be made up of an Textbox instrument USA, and it consists of a modified hardware architecture. Then the TMS320C54x, it has more internal bus and on-chip peripheral, large size arithmetic logical unit, and a very rich instruction set than the 3MS320C5X family. This processor can execute 40 to 120 million instruction per second. So in short, we can call as MIPS. So it is a more time period which is going to be here. Then features of an TMS320C54X. It is a 16-bit CPU and a 25 to 8.3 nanosecond cycle instruction execution time, which is going to be considered here. And it has a 16-bit external program memory, 16-bit data memory, and 16-bit IO address, that is input output address. Then a programmable timer and a PLL phase lock loop, which is going to be considered as the features of this TMS320C54X, and it considered as high triple standard. Then this processor also will be used in 5 volt and 3 volt, that is for a power dissipation mode and a power down mode. In both the mode we can able to be used at 5 volt and 3 volt. Then we are going to be see about a pin diagram of a TMS320C54X processor. So in market we are going to be available two types of packages will be there. So one is a thin quad flat packages, another going to be in a ball grid array. So these are the two types of 5x processor will be available in the market. So this TQFP packages will be available in 100 pin, 128 pins and 144 pins, whereas in the ball grid also is going to be available for 144 pins. Now you can see here a pin diagram of an TQFP of an 100 pin processor. This is an 54x processor. It consists of 100 pin. Then a functional grouping of an pin diagram which have been shown here. So all the input and output ports and then data bus, address bus, whichever is going to be grouped together. So the name which is going to be called as a grouping of the pins. Then we are going to see here is architecture of TMS320C54X processor. So this is a simplified architecture of a TMS320C54X. You can see here this dotted line which is going to be shown here. This is an one part and the second part and third part. That is this entire architecture is going to be further divided into three parts. So this is an entire one part. This part which is going to be called as an CPU, and the second part which is going to be called as an on-chip memory unit, and the third part which is going to be called as an on-chip peripheral unit. So these are the three main parts which is going to be presented in an architecture of an TMS320C54X processor. Then we are going to be see here in a general things about an 54X processor. So this processor is a modified hardware architecture, and it maximizes the processing power by providing 4 pair of separate bus structure, 3 pair of data memory, and 1 pair of program memory. In this processor, a separate program and data memory space allows simultaneously. For example, we can call this a 2 read and 1 write operation can be performed in a single cycle itself. So that is a special data memory which will be there. The architecture can be broadly divided into 3 major, that is we have been discussed in the previous itself. That is, they are CPU, central processing unit, on-chip memory unit, and on-chip peripheral. So like this, we are dividing that main architecture. The main architecture which is going to be divided into 3 major parts. One is CPU, on-chip memory, and the other one is on-chip peripheral. So the functional unit of the CPU are 40-bit arithmetic logical unit and two number of 40-bit accumulator, that is ACCA, that is accumulator A and accumulator B. These are the two number of 40-bit accumulator. Then a barrel shifter present and a 40-bit adder and a CSSU. CSSU means compare, select, store, unit. So that is going to be called as an CSSU, and exponential encoder, status register, data address generation unit, program address generation unit, and system control interface. So these are the unit which is going to be presented in that CPU. So it's a central processing unit of that architectures. Then in the main on-chip memory unit, which is going to be consists of 2K to 48K words, that is a kilowords of an 16-bit ROM will be presented, and 5K to 32K words of an 16-bit RAM will be presented, and a direct memory access controller also will be present, and then external memory interface which is going to be present in that on-chip memory unit. In the third part, we are going to be see here this on-chip peripheral. So in this on-chip peripheral, the general purpose IO pins will be there, clock generator, timer, standard serial port, buffer serial port, and a host port interface. So like this, so which is going to be presented in that on-chip peripheral unit. So here the total of an TMS320C54x processor is going to be an 192 kilo addressable 16-bit which is going to be presented. This 192 which is going to be further divided into in three parts. So that is 64 kilo program memory address, and then 64 kilo data memory address, and again 64 kilo input and output port address space, IO port space. So this total we are adding means 64 plus 64, the total we are going to be get 192 kilo. So the total space which is going to be divided into three. So for one is for program memory, another one is for data memory, and another going to be for IO port. Then now we are going to be see about the functional unit of CPU. So the various functional unit of an TMS320C54 processors are, which is inbuilt in that functional unit is arithmetic logical unit, accumulator A and B, barrel shifter, 17-bit multiplier, 40-bit adder, and a compare, select, and store unit, exponent encoder, data address generation unit, program address generation unit. First, we are going to be see here an arithmetic logical unit. Now we are going to be see about an detailed functions of an CPUs. So this arithmetic logical unit is a 40-bit ALU. It can perform a wide range of arithmetic and logical function in a single clock cycle itself. So therefore the result is going to be either in accumulator or in memory, which is going to be the designation of your arithmetic logical operation. Then the arithmetic logical unit operation involves two datas. One of the data which is going to be from a barrel shifter, and the another one is going to be from an accumulator. The next functional unit is going to be seen here is accumulator. It is also in a 40-bit accumulator, but here it has a 240-bit accumulator will be present in this 54x processor. So what are the two accumulator means accumulator A and accumulator B. So this is the name of a 240-bit accumulator, ACC A and ACC B. The accumulator can act as a source or designation for an arithmetic logical unit and that multiplier and adder. For example, if you are going to be given any additional subtractor sum means, the arithmetic logical unit is going to be a designation of an accumulator processor. Then this accumulator are going to be divided into three parts. One is a God bit, another one is a high order, third one is going to be a low order word. This God bit range is going to be 32 to 39, and this high order word is going to be ranges from 60 to 31, and the low order range is from 0 to 15. So a total accumulator bit which is going to be present from 0 to 39. So from 0 to 15 it is in a low order, then 16 to 31 it is in a high order, then 32 to 39 is going to be a God bit order. So total bit which is going to be present here is 39. Then the next unit is going to be a barrel shifter. So in this TMS320C54x, the 40-bit barrel shifter can perform an 0 to 31 bits left side and then 16 bits to the right shift side. And along with the exponent encoder can be normalized that accumulator content. Then this barrel shifter are used to realize the following operation. One is for pre-scaling, that is for before the arithmetic logical unit operation, and second one for an logical arithmetic shifting, and the third is going to be a normalizing accumulator, and the fourth one is going to be a post scaling. This type of 4 operation we can also use that barrel shifter. The next unit is going to be a multiplier and adder. So one of the input for a multiplier can be supplied from a memory register, and the other input is going to be supplied from that data memory. For example, if you are giving an additional instructions, means in addition the multiplier and an ALU together can perform an MSU operation and an ALU operation in a single instruction cycle itself. So therefore, this parallel operation can be used for efficient implementation of a DSP computation like convolution, correlation, and filtering. The next unit is going to be a compare, select, and store unit. The compare, select, and store unit is an application-specific hardware unit dedicated to perform add, compare, select operations in order to support various butterfly algorithms used in the equalizer and then channel decoder. The input of an CSSU, that is compare, select, and store unit for comparison or from accumulator, and then output is stored in data memory. The status of the comparison are also stored in least signification bit. The next unit is going to be an exponent encoder. The exponent encoder is an application specific hardware device dedicated to extract the exponent value, which is dedicated to extract exponent value from floating point data in that accumulator and stored in that T register. Here that is going to be shown here the example. This is an instruction that is EXP SRC. When you are giving this instruction is going to be used to extract the exponent and save in T register. The next is set of an instruction which is shown here, that is NORM SRC, DST. For this instruction, this exponent encoder is going to be used to normalize the accumulator and using that exponent in T register as an count value. So like this, the instruction which is going to be used in this encoder. Here the next unit is going to be a data address generation unit. The data address generation unit consists of two number of auxiliary register arithmetic unit, that is ARAU0 and ARAU1. So AR means arithmetic register, okay, so that is going to be called as an auxiliary register arithmetic units. Then 8 number of auxiliary register AR0 to AR7, auxiliary register 0 to auxiliary register 7, and then 16-bit circular buffer size, and then a 16-bit stack pointer. Then auxiliary register also is used to hold the data memory address in indirect addressing mode. The next unit is going to be a program address generation unit. The address generation unit is going to be consist of a 5 register, namely program counter, repeat counter, block repeat counter, block repeat start address register, and a block repeat end address register. So these are the 5 registers which have been presented in a program address generation unit. Then the status register. The status register is going to be consists of a 2 16-bit status register will be there. One is ST0 and ST1. So which holds the status of an arithmetic logical unit results. And also it is going to be used for various bits of interrupts control, hold mode and accumulator shift values. The format of the status register and the function of various bits of a status register are here shown. So here this is a format of a status register, that is for status register 0. So there is a two types status register. Thus the first we are going to be see here is status register 0, ST0. So this is an format. From 0 to 15 there is a register which is going to be presented here, the bit. Some the various functions which have been shown in this tabular column itself, that is from 15 to 13 bit, we are going to be called as an ARP. What is ARP? That is an auxiliary register pointer to select the arithmetic register. The 12th bit which is going to be called as an 1, that is TC. The value is 1. The name is going to be TC, that is a test control flag bit which stores the result of an arithmetic logical unit. And the 11th bit is going to be C, that is going to be carry bit. 10th bit is going to be called as an OVA, that is overflow flag accumulator A. Overflow flag accumulator A, and the 9th is OVB, overflow flag accumulator B. So like this, from the remaining part is the 8 to 0, it is shown as a DP. DP means data memory page pointer. So this is for a status register 0. Similarly, that we are going to be see here is status register 1. The status register 1 also, which is shown here from 0 to 15, there is a bit which will be presented here. The 15th bit which is going to be called as an BRAF, that is a block repeat active flag. Similarly, CPL is going to be called as a compiler mode bit. XF is going to be called as an external flag pin, and HM which is going to be called as an hold mode, and INTM interrupt mode bit, and OVM, already we know that OVM, what is an OVM? Overflow mode bit, and then XHM is going to be an sign extension mode bit, and C16 is going to be an 7th bit which is going to be called as a dual 16-bit precision arithmetic mode selection bit. FRCT is a fractional mode bit. CMPT is going to be a compiled mode bit, and then ASM is from 0 to 4 is going to be called as an ASM accumulator shift values. This status register can be stored into a data memory and loaded from data memory also, thereby allowing the processor status to be saved and restored from subroutines. Then the last functional unit which is going to be see here, that is a CPU memory map register. In TMS320C54x has a 32 number of 16-bit CPU register that are mapped into page 0 of data memory space. These memory map registers includes registers of data and program memory, address generation, various status, and control registers of CPU, and then accumulator. So now we are going to be see here is the memory mapped register along with memory address which have been listed in this table. That is from 0 to 31, the memory map register which have been shown here. This is going to be further divided into 3 parts. Then it will be utilized in that central processing unit. Next, we are going to be see here in a comparison of features of TMS320C5x processor and TMS320C54x processor. Now we are going to be compare both the processor according to that features. So here these are the features which is going to be presented, different kinds of features which will be available when comparing both the processor. That is for a program bus, we having only one program bus PB which is there, and a data bus for an 5x processor we have only one data bus, whereas in the 54x processor we have 3 data bus. One is for specially for a read, specially for a write operation also we are considering a data bus. In 5x processor the address bus is 2 address bus will be presented. In the 54x we are getting 4 address bus. So this is an advanced version of a 5x processor. A 54 TMS320C54x is an advanced version of a 5x processor. You can see here main arithmetic logical unit also is consisted 32-bit only in 5x, whereas in the 54x we consider here 40-bit accumulator arithmetic logical unit. Okay, here the accumulator is also in 32-bit, here 40-bit, and two accumulator will be present, accumulator A and accumulator B. Then for a barrel shifter, so barrel shifter is in a 16-bit, so here 40-bit will be there. And then multiplier is in a 16-bit, here 17-bit will be there. And adder is in 32-bit, here 40-bit will be there in 54x processor. Auxiliary register, only one auxiliary register will be presented in 5x processor. Okay, whereas in the two register will be presented in that 54x processor. Auxiliary register 0 and auxiliary register 1. Similarly, several features will be presented here, that is a block repeat register and a circular buffer register and a wait stage register and a host port interface. So these are the features which have been presented in TMS320C5x and 54x. These are the different features which is going to be presented in two processor. Now we are going to be see here the common features which is presented in both TMS5x processor and 54x processor. So these are the common features will be presented. There will be no variation for a two processor. Auxiliary register AR0 to AR7, that is 8 auxiliary register will be presented. Status register is 16-bit, and then a program counter is also in a 16-bit. Then interrupt register is also in a 16-bit. General purpose IO port, hardware timer, clock generator, and a synchronous serial ports. So these are going to be an same features will be available in 5x and 54x processor also. The next we are going to be see here in the special features which will be available only in TMS320C54x processor. So it will be available only in TMS320C54x processor. So what are the special features which is going to be available here is a stack pointer, extended program memory, multi-channel buffer serial port, internal programmable, and on-chip ROM. So these are the special features which will only available in TMS320C54x processor. Students, so far today that we have been discussed about an overview of an TMS320C54x processor and a feature of a digital signal processor, architecture of an TMS320C54x digital signal processor, functional mode of 54x processor, and a comparison feature of TMS320C5x and 54x processor. Okay, thank you.